Hi, my name is Alex Zhu, and I'm a Urologic Oncology Fellow at University of Washington. The premise of our research project revolves around a simple question. Have you ever thought about what's in your water? What if I told you that the water you drink increases your chances of developing a urological cancer? Although this might sound far-fetched, there is some potential validity to this. Water contains hundreds of chemicals, elements, and potential contaminants, one of which is arsenic. Arsenic is a naturally occurring element in the Earth's crust, but can contaminate our drinking water and lead to many detrimental health effects. For instance, it is a known carcinogen and increases the risk of many urological cancers such as bladder, kidney, and prostate. To limit the amount of arsenic in our water, the U.S. Environmental Protection Agency proposed a regulation in the year 2000 to reduce the maximum amount of arsenic in our water to 10 parts per billion. However, there is still concern that this cutoff is not stringent enough and may still lead to increased levels of urological cancers even at these low levels of arsenic. Thus, we wanted to ask, in Washington state drinking water, what is the association between bladder, kidney, and prostate cancers at arsenic levels below the 10 part per billion cutoff? In other words, should the cutoff be lowered? To answer this question, we assessed data from the Washington State Department of Health and reviewed all their arsenic tests on water in Washington between 2000 and 2018. We also reviewed all the incident bladder, kidney, and prostate cancers diagnosed between 2014 and 2018. We chose these dates in particular as 14 years is known to be an adequate latent period between a potential exposure, such as arsenic, to the subsequent development of cancers. During this time, we reviewed over 46,000 unique arsenic measurements and identified over 19, 8, and 6,000 unique cases of prostate, bladder, and kidney cancers, respectively. We found that the average arsenic concentration in water was 3.76 parts per billion, but that the counties with higher arsenic levels seemed to overlap with those with higher cancer incidence rates. We also found people who were exposed to the highest amounts of arsenic had higher rates of developing bladder, prostate, and kidney cancer. Ultimately, we present the first study assessing incident urological cancers since the proposal of the 10 part per billion arsenic cutoff. We found increased rates of incident bladder, prostate, and kidney cancers at levels below the cutoff, which suggests that U.S. drinking water standards might not be stringent enough to reduce the risk of urological cancers even at low levels of arsenic exposure. Thank you.